Okay, let us now talk about how we can determine the domain and the range of a multivariable function. In this particular lesson, you must be able to determine or evaluate the value of the function in two or more variables, and that you must be able to analyze what the domain of the said function would be. Okay, let us recall a function of one variable, y equal to f of x. In this given notation, x is the independent variable, y is the dependent variable. Now, the terminology dependent and independent variable likewise would extend to functions of more than one variable. So, if we are given the function z is the f function of x, y, x and y are the independent variables of this function with z the independent variable. Or if we have the function w dependent on x, y, and z, then these three variables x, y, z are the independent variables of this function, where w is the dependent variable. So formally defining a function into variables, a function of two variables x and y is a rule that assigns a unique real number to f of xy to each point xy in some domain D in the xy plane. And that if we're talking of w function of xyz, then we talk of a rule that assigns a unique real number to f of xyz to each point xyz in some set D in the three-dimensional space. So when we talk about the natural domain of the function, this will simply pertain to the values of the independent variable that would yield a real value for the dependent variable following the rule as defined by the function or following the restriction as stated in the given rule. So working with a multivariable function, such as in this case, where z is defined equal to the square root of y minus x squared, how do we determine the natural domain of the said function, and how do we evaluate the value of z at x equal to 0 and y equal to 1? So for our solution, we first evaluate what is z value at x equal to 0 and y equal to 1 by directly substituting into this expression 1 for y and 0 for x to give us the value of 1. So z at x equal to 0 and y equal to 1 is equal to 1. Now, as to what the natural domain of the said function is, we investigate now what values of x and y would render the radicand not negative. Because if z is to be with real value, it should be that the radicand of this square root function should never be negative. It can be 0 or something positive. Hence, we investigate what the values of x, y, and z would be so that the radicand y minus x squared is greater or equal to 0. Now, this would lead us to a relationship between the independent variables, and that in this particular case, the radicand would be greater or equal to 0 when y is greater or equal to x squared. So, what we are saying is that the natural domain of the function f is consist of all points in the xy plane for which y would always be greater or equal to x squared. Okay, so you can view the set of all points in relation to the graph of a parabola given by y equal to x squared and locate at where the points would be positioned with respect to the parabola that would satisfy this condition of y equal or greater than x squared. Now, in this other example, we will be working with a function that is dependent on three variables x, y, z, where the f function of x, y, z is defined the square root of the quantity 1 minus x squared minus y squared minus z squared. Okay, and that we evaluate the value of f at 0, 1/2, and negative 1/2. Again, for our solution, we first evaluate what the function value of f is at x equal to 0, y equal to 1/2, and z equal to negative 1/2, substituting these values in there to render or to give us the square root of 1 minus the square of 0 minus the square of 1/2 minus the square of negative 1/2. And when you evaluate this expression here, that will just be equal to 1 divided by the square root of 2. Or you may want to express this as square root of 2 over 2. Investigating now what the domain of the function is. Again, since this is a square root function, then the value of f would be real when the radicand 1 minus x squared minus y squared minus z squared is not negative. So you force this to have a value greater or equal to 0, or you may view it in terms of the sum. X squared plus y squared plus z squared is less than or equal to 1. So if you are to describe the natural domain of this function, then the domain of the function would be composed of x, y, and z, where x squared plus y squared plus z squared is less than or equal to 1. Or viewing it graphically, this is composed of all points that will be on or inside the sphere whose equation is an x squared plus y squared plus z squared is equal to 1. So to recap what we have in this lesson, if we are given a function z which is dependent on two variables x and y, then the natural domain of this function z is composed of all values of x and y that would return a real value for z, and that the set of all points x and y now would constitute the natural domain of the function z, f function of x, y.